Hi everyone! Today we're continuing Chapter 4 in Module 2, and we're going to discuss atomic numbers and mass numbers for elements. So all atoms of an element have the same number of protons and the same atomic number. So last time we did talk about subatomic particles and how every atom contains protons and neutrons in a nucleus, as well as electrons, which are outside of the nucleus. Now, a particular element, or I guess an atom of a particular element, will have a very specific number of protons. Now, the atomic number is a whole number that's specific for each element, and it will be the same for all atoms of a particular element. Now, a key thing is that the atomic number is equal to the number of protons in an atom. And the atomic number appears above the symbol of an element in the periodic table. So down below we have sodium, which remember has the symbol Na, and just above that is the number 11. Now, 11 is the atomic number for sodium, and it's also the number of protons that's in an atom of sodium. Okay, so let's actually go to our periodic table, and you'll notice that each element has a number. Oops, didn't mean to do that. Let's see, we want the pen. But each element has a number listed above it. And again, sodium has the number 11 above its symbol. Lithium has the number 3. Hydrogen has the number 1. And also, you'll notice if we go from left to right, the numbers just increase by 1 each time. So we go 1 for hydrogen, 2 for helium, 3 for lithium, 4 for beryllium, 5 for boron, and we keep going. Now, those numbers, again, remember, are also equal to the number of protons for an atom of each type of element. So if we had an atom of boron, we would find 5 protons in that atom. If we have an atom of lithium, there would be 3 protons, etc. So all of the elements are listed according to the number of protons that they have. All right, let's go back to our slides. Okay, so again, the atomic number is equal to the number of protons for an atom of that particular element. So, for example, we just saw that the atomic number of hydrogen is 1. So every hydrogen atom has 1 proton. So the atomic number is 1, so every hydrogen atom has 1 proton. Now, the atomic number of carbon is 6, so every carbon atom has 6 protons. And then copper, its atomic number is 29, so every copper atom has 29 protons. So, not too bad. The periodic table tells us how many protons every atom of an element has, which is nice and handy. Now, what this means, though, is the number of protons identifies the element. So the number of protons for an element will never change. So no matter what atom of copper we have, let's say we pick 5 different atoms of copper, they will all have 29 protons. So that will never change for copper or carbon or hydrogen. They all will maintain the same number of protons because that's what identifies the element. So again, if we were to zoom in on different elements, so let's say we zoomed in on lithium and we said the atomic number of lithium is 3, that means lithium has 3 protons. So if we could use a super special microscope that can look at a nucleus of lithium, we would find 3 protons in that nucleus. And then for carbon, we said the atomic number is 6. So if we could zoom in on the nucleus of an atom of carbon, we would find 6 protons in the nucleus. All right. Now, for now, we're going to assume that atoms of an element are neutral. So that means that the net charge of an atom is 0. So remember, protons have a positive charge, electrons have a negative charge. So if an atom is neutral, that means we need the same number of positive charges and negative charges. So for neutral atoms, the number of protons is equal to the number of electrons. So as an example, aluminum has an atomic number of 13, which means that it has 13 protons. And if it's neutral, that means it also has 13 electrons. So we have 13 positive charges and 13 negative charges in an atom of aluminum, or in a neutral atom of aluminum. So the 13 positive charges will cancel out the 13 negative charges, and we get an overall charge of 0 for that atom. Now, later on, we'll learn that you can actually have more electrons than protons or less electrons than protons, and that will give an atom a charge. But for now, just assume that atoms are neutral. So the number of protons equals the number of electrons. Okay, so let's do a quick learning check. Let's use the periodic table to fill in the atomic number, the number of protons, and the number of electrons for each of the following elements. Okay, so we've got N, Zn, and S. So which element has the symbol capital N? Nitrogen. What about Zn? What does that stand for? Zinc. And then what about capital S? Which element has the symbol capital S? Sulfur. All right, so let's look up those 3 elements and their atomic numbers. We'll go to a periodic table. Let's see, I'll use a different color here and a highlighter. Okay, so nitrogen, capital N, that is right here. And that has the atomic number 7. What about zinc? Can you find zinc? Zn? So that is right here. And then what about S, sulfur? That is right there. Okay. So nitrogen has an atomic number of 7. Zinc has an atomic number of 30. And sulfur has an atomic number of 16. So those are here, here, and here. Okay. So let's write those down. All right. So nitrogen had an atomic number of 7. Zinc had an atomic number of 30, and sulfur had an atomic number of 16. Okay, so now that we know the atomic numbers, remember that's also equal to the number of protons. So how many protons does nitrogen have? 7. How many protons does zinc have? 30. And how many protons does sulfur have? 16. Okay, and then we also said that for neutral atoms, the number of protons will equal the number of electrons. Okay, so assuming that these elements or their atoms are neutral, how many electrons would be in an atom of nitrogen? 7. So we have 7 positive charges and 7 negative charges, so they'll cancel each other out, and then that atom of nitrogen would be neutral. What about zinc? How many electrons would we expect? 30. And what about sulfur? How many electrons? 16. Okay, so once you know the atomic number for an element, which you can always look up on the periodic table, then you can figure out how many protons you have in an atom and how many electrons. So super easy. And there's the solution slide if you want to look that over later. Now, there's another number we need to discuss, which is called the mass number. So this represents the number of particles in the nucleus. So remember, in the nucleus, we have both protons and neutrons. So the mass number is equal to the number of protons plus the number of neutrons. Now, the mass number is always a whole number because in this particular case, we're considering just one atom. So the mass of a single atom does not appear in the periodic table. We would be given the mass of a single atom. Now, remember previously we said that protons have a mass equal to about 1 atomic mass unit. And we said that neutrons also have a mass of about 1 atomic mass unit. So let's say we have a hydrogen, or actually let's say we have a carbon atom, and let's say that it has 6 protons and 6 neutrons. So if we add up the masses of all of the protons and all of the neutrons, that would give us a mass for that particular atom equal to 12 AMU. But remember, this is for a single atom of carbon. Now here are some other examples. So if we look at hydrogen in this table, and this is table 4.6 in your textbook, hydrogen has an atomic number of 1. So that means it has 1 proton. Now, its mass number, we're being told, is 1. And that's already taken into account by that 1 proton. That 1 proton has a mass of 1. So that means we actually don't have any neutrons here. If we did have a neutron, then the mass number of hydrogen would be 2 or more, for instance. But the mass number is only 1. Now, we also then can conclude, because we have 1 proton, we must have 1 electron. So remember, the mass number is equal to the number of protons plus the number of neutrons. Or another way to put it, the mass number is equal to the atomic number plus the number of neutrons. Okay. And I use the pound symbol or the hashtag symbol for number sometimes. So I'm not writing hashtag protons, but that would be a cool hashtag. Okay, so nitrogen. Let's look at nitrogen. Nitrogen has an atomic number of 7. And let's say we find an atom of nitrogen that has a mass number of 14. Okay, so just from that, we can tell that we have 7 protons because the atomic number is 7. Oh, my pen stopped working. There we go. So looking at the equations above, what we can do is rearrange the equation to solve for the number of neutrons. So we can say that the number of neutrons in an atom is equal to the mass number minus the number of protons, or minus the atomic number, since those are the same thing. Okay, so for nitrogen, we know that we have a mass number of 14, and we have 7 protons. So the number of neutrons must be 7. 14 minus 7 is 7. Okay, and we can see from this table that that works out. We have 7 neutrons. And remember, protons have a mass of 1 atomic mass unit, and neutrons also have a mass of 1 atomic mass unit. So if we add the number of protons and the number of neutrons together, and each one is worth 1 atomic mass unit, that gives us a mass number of 14. So it all kind of ties together. Now, we also know that for a neutral atom of nitrogen, we should have the same number of electrons as protons. So we would find that we have 7 electrons in this atom. Now, things can start to get more complex as we get into atoms that have a lot of protons and neutrons. So for instance, as we go down this table and look at gold, which has the symbol Au, the atomic number of gold is 79. The mass number for an atom of gold might be 197. And from those two numbers, we can then figure out how many protons, neutrons, and electrons we have. So the atomic number, remember, is equal to the number of protons. So we would have 79 protons. And then we can take the difference between 197 and 79, and that will give us the number of neutrons, which is 118. Now, we can also determine the number of electrons because that will be equal to the number of protons. So the number of electrons is 79. So the first few elements are pretty easy to figure out, but then once you start getting into more complex elements, it can be more difficult to figure out how many protons, neutrons, and electrons you have. Although I would argue that the most difficult thing to figure out is the number of neutrons. All right, so just to summarize, remember that the number of protons is equal to the atomic number, and then the number of protons plus the number of neutrons is equal to the mass number for an atom. So remember, we can rearrange that equation to solve for the number of neutrons if you know the mass number and the number of protons, or the atomic number. So feel free to pause the video and write these equations down because they are really useful. Okay, so let's do a quick learning check. An atom of lead, which has the symbol Pb, and remember that comes from the Latin name plumbum. It's one of my favorite Latin names. An atom of lead has a mass number of 207. And we want to figure out how many protons are in the nucleus, how many neutrons are in the nucleus, and how many electrons are in the atom. So feel free to use your periodic table to look up lead and its atomic number, and then try to figure out from the atomic number and this mass number how many protons, neutrons, and electrons this atom has. And when you unpause the video, we'll go over it together. Okay, so let's look up lead on our periodic table. All right, so lead is number 82 on the periodic table. So its atomic number then is 82. So let's write that down. So we know the atomic number and the mass number. So how many protons are in the nucleus? 82. It's the same as the atomic number. So now let's figure out how many neutrons are in the nucleus. So remember, the number of neutrons is equal to the mass number minus the atomic number, or the number of protons. And also remember, the mass number is the number of protons plus the number of neutrons. All right, so we'll just plug in what we have. So the mass number is 207, and the atomic number is 82. Okay, so that would be, let's see, do some quick math here. I haven't had enough coffee today. 125, there we go. At first I had 105 and I was like, that's not right. Okay, so we have 125 neutrons in the nucleus. So now how many electrons are in the atom? 82, same as the number of protons. All right, so hopefully that helps you to better understand protons, neutrons, electrons, and how they contribute to the mass of an atom. So here is the solution slide if you need that later. And in the next video, we're going to discuss something called isotopes. And isotopes help us determine the overall mass for a bunch of atoms of a particular element. So far we've just focused on single elements, but what if we have a huge number of atoms in a sample of an element? How do we figure out the mass of that? So we'll go over that next time.